Yeah, so thank you so much for joining us. I'm going to start introducing our the speakers, the research team that has been working on do bias models have bias thoughts. I'm going to start with Abdurrahman. Can you say hi to folks so you know where you are? Abdurrahman is a research scientist at Amazon. During his PhD, he has worked with Professor Esra'a Saleh at Mila on understanding why language models take discriminatory decisions based on gender, race, sexual orientation, or religion. He also worked on developing methods to mitigate and measure these biases. His research interests include NLP, fairness, and responsible AI. And second, we have also Swati. Swati, do you want to say hi? Swati is a CS PhD student at Emory University. Her research focuses on applied natural language processing for healthcare using data such as like the electronic health records, EHRs, social media, and patient narratives. She is also actively working on understanding the biases in large language models and how that affects often disproportionately certain populations. And then we have Shivank. I don't know if he joined. If you joined, say hi. If not yet, it's okay. We're going to catch up later. But Shivank also was part of the team. He's a final year undergrad at the Indian Institute of Technology, Roorkee. He was previously working with Adobe on video generation models. His research focuses on the field of LLMs and VLM alignment, mainly exploring post-training RL-based techniques for generative models, and also in the field of diffusion models and their applications. And also we have Reem as well. Do you want to say hi to everyone? Reem is a PhD student in computer engineering at Cohere University. Her research focuses on applied NLP for healthcare and the Arabic language, quantum machine learning, and efficient model quantization. She has worked on developing resources for culturally inclusive Arabic language large language models, advancing healthcare applications such as cancer diagnosis and health. And she also contributed to shared tasks in sentiment analysis, sarcasm detection, and dialect identification. Her broader interests include NLP, machine learning for healthcare, quantum AI, and model efficiency. So thank you so much for the research team for joining us. We're so excited for you. And so we want to start off this session by just understanding how this research collaboration came about and how it all started. So I'm going to give the floor to Ruchira, who's going to be managing the question session.
Yeah, hi guys again. Thank you so much for joining. Let me get right into the questions. So the first question is, how did this collaboration actually start, and what was the timeline for you guys? What did it look like?
So I think I can start. I remember Esra'a, you probably remember Sarah Hooker's defense. So Esra'a and I were attending the PhD defense of Sarah Hooker at Mila. Mm-hmm. And then Sarah Hooker was talking about her future works and the directions that she thinks are important. And most of these works already had her name on those papers. And then I was telling Esra'a that this is really impressive. Like, how come she participated in all of these works simultaneously? And Esra'a said that you can also come and pitch your ideas and find people to work with you and find collaborations. And it's open science. We do that at Cohere. I said, yes, I'm interested. So I joined, I think, a week later or something. And then I talked about one of the ideas that I had during my PhD. And I was lucky that I got those 3 brilliant students who worked with me. And this is how it happened. Yeah, that was October when we started last year.
That's super inspirational to hear that, just talking with something and it led to this whole paper at a conference. That's super nice to hear. And so how did you guys structure the collaboration? Did you meet weekly? How did you break up the tasks, and how did that go about? And the time commitments for each of you guys, what did that look like?
Swati, do you want to take this one?
Yeah, I think I can take this one. So I remember when we met it was clear that the goal and the final outcome is pretty specific, right? Like Abdul did an amazing job in like anticipating what we are going to do, and also it was mostly like if our results table, we just need to put the numbers in it, right? Like, that was the kind of clarity we had. So Abdul, in case I never appreciated and really appreciated that you came up with such clarity, and so we decided that it would be great to have like a calendar block for every week, because otherwise things drift away, you get busy, and it's like in order to keep everything running in momentum, we just found like one common time, and thankfully it worked for all of us because everyone was in different time zone. Abdul in Canada, me in US, Shivak in India, Reem in Egypt, so it was completely different time zones, but we somehow figured out one day common times. And so it was on every Monday. The first week during the morning was this meeting. And like over the weekend, because I was also working on my own research, I would like just work on this project. So it was kind of like my side baby project. But at the same time, I was able to spend my weekends, just run the experiments and get results to the rest of the team by Monday. So that was the time.
Cool. That sounds interesting. And yeah, I mean, it's so hard for us researchers, I guess, to focus on a topic, right? So it's great that you guys actually made through it, because I feel like we get involved in so many projects and then it goes haywire. But this direction, yeah. And I think one concern that our community often has with starting collaborations or project is compute, the big devil in research. So how did you guys manage that? And was it like mostly free tier collab or Kaggle, or did you all have access to your own compute clusters?
Reem, you want to talk about this? I want everyone to talk.
Yeah, sure. So regarding compute, I think everyone participated on their own ways. So I think Swati did have her access to her own compute. So we started like to, see what is everyone have access to, and, to find some common baseline which work for everyone, so that we don't burden someone with all experiments and work and others do not participate as well. So we started like knowing what everyone have access to, and I think everyone did have an access to their own compute with regard to their institution. I think Swati and me did have like a compute from our institution. I think Shivang did use a freeze and did have like an access to another compute. Yeah.
Cool. And did you guys like start with smaller, simpler models and experiments, or did you like ramp up the compute very initially? How did it work?
Swati?
Yeah, so I think we
sorry.
did. Yeah, go Swati. Yeah.
Oh, I didn't mean to, but I remember like we had bigger plans. But at the same time, we also have to be realistic, right? Like, because computational resources are so costly. So we just like, first of all, calibrated what each and every one of us has, right? Like, so I had my own resources. Abdul also had the Canada compute thing, if I'm saying that right. So we afterwards, then we calibrated, okay, so this is the amount of this, these are the models, these are the 7 billion or 8 billion parameter models that we can run. And that's it. Right. So we were like, honestly, at the very get-go, we were like very clear in terms of calibrating what resources we have and also aligning the goal of the project accordingly, and not to aim something which was way beyond the resources that we had. So I think the calibration part was like done very, very, very early on.
That sounds incredibly efficient. You guys should do a blog on this. It would probably go viral.
I agree. Oh my God, yes. I think a lot of people would benefit from the experience.
Definitely. And yeah, so I think this is one of the last questions I have for you guys in terms of, so there's two things I'm going to ask you. One thing that you felt that really worked in this collaboration, it could be anything, like starting from when you guys met or how you guys, divided projects, anything. And one thing that you feel that you could have done better in hindsight. Any of you guys can take the questions. It's open.
I think for me, I like the fact that everyone, so Swati, Shivank, and Reem, they all had this desire and interest to always improve and come up with better ideas. So this is something that was really working well, given that we were in 4 different countries. It never faded. So when people start volunteering, it's not something that they are obliged to do, and they all have other things happening in their lives. But despite this, their interest never faded throughout the 5 months. So for me, that is something that exceeded my expectations. Yeah, their desire to just keep working until we reach our goal.
That's
I think I would just like to piggyback to Abdel's comment here. Honestly, that was the best part. Like, we all were involved in this project from the very beginning towards the end. I'm myself surprised how efficiently involved we were. And I think having the meetings was a bigger part of that, right? Because we had to make it to the meetings no matter what. We all saw fall breaks, we all saw New Year, we all saw Christmas together. So it was also part of growing together at the same time. And second thing is, I would attribute that to Abdul's mentorship also. Honestly, he was the reason I just wanted to be involved in the project, and the kind of guidance that he would give to us every week. Honestly, that was the best part, at least for me. So yeah, I think it was both ways, right? Abdul was able to guide us, direct us. If we would just go in another direction, he would be just come back and focus. Okay, this is what you want to do. Just don't broaden your focus to focus on this one task at the time, at this week, and the next week we will revisit. So I think we were interested for sure. We could see that in each and every one of the team members, but at the same time, having a mentor who is able to kind of control your thoughts and help you guide in a specific direction was super. So thanks, Abdul.
And what is one thing that you guys think you could have improved in hindsight? And there might be many things, but feel free to go with one.
Good question.
Yeah.
It was just that good.
I think I could just quickly cover and then go, if that's okay. I think for me, what we could have improved was mostly from the research point of view, not from the team dynamics. I think team dynamics was perfect. Honestly, if you guys would I would like to collaborate again. So up to you. The ball's in your court now. But to be honest, I think there were certain aspects of the research that we wanted to focus on, but at the same time, we wanted to be realistic, right? All of us have our own primary jobs. We are PhD students, Ashima is a master's student, so everyone has to move on to the next stage. But at the same time, we wanted to give something very strong, and I think this paper does an amazing job in that. But at the same time, being the researchers that we are, we had so many more thoughts that we wanted to include in this paper. So many more data sets that we wanted to do it. But yeah, there's only so much we can do. So yeah, those were the only things that I can think we could have done more, I guess, perhaps. But considering I think this is a very decent job.
Yeah, I think that completely makes sense. There's a point that we researchers have to stop, otherwise we just keep going forever trying to get to that optimal level of contribution. But yeah, I think that totally makes sense. And thank you guys so much for answering the questions. And I'm going to hand the mic back over to Esra for the rest of the proceedings.
Yeah. Thank you, guys. This was super insightful. I'm sure a lot of people are also asking themselves, how do these collaborations start and end up? So this is really insightful for them to understand the process from start to end. So, and yeah, congratulations on the publication. Absolutely great work. And so now maybe one of you will share your screen just so that you can start. Swati, thank you so much for joining us.
I'm sharing it. I just realized that I have to do something on the settings side.
All right. Nice. Yeah, we totally see. Oh, yeah.
We can see your screen, but you're muted if you're saying something.
Yeah.
Now it's good?
Yeah.
Awesome.
All
You hear me and you see my screen, right?
yeah.
Perfect. Thank you.
Okay. Should we start?
Yeah, of course. Yeah. Go ahead.
Okay. I also don't see the chat, so if there are any questions, I'm always pro asking questions during the presentation compared to after. It just makes it more interactive, but it's up to you. It's just my own preference.
Sounds great. I'll manage the chat.
Okay. So yeah, I'm very excited to be here. Thank you so much, everyone in Cohere, and more specifically Esra'a, who actually started all of this. So today we're gonna talk about our recently accepted paper, which has the title "Do Biased Models Have Biased Thoughts?" My name is Abdurrahman, or just Abdel. I'm a PhD student at Mila, and I worked with three brilliant students from those three other institutes: Emory University, IIT Roorkee, and Cairo University. This is my lab. Esra'a probably knows. This is how it looks like during the summer. This is me. And these are the brilliant students who led this work. They have done all of the hard parts, all of the coding was done by them. Swati, Shivank, and Reem, thank you so much. So first of all, before I dive into this topic, I just wanted to talk about why I chose to work on fairness, because this is also my entire PhD. So as you see, the language models are now being more widely used since ChatGPT became popular in 2023. And as they impress us more, it makes sense to think of also what kind of harms do they have. So I started thinking about fairness because I saw a lot of problems that come when language models are deployed more widely. So I'm just listing some of the LLM harms, but of course you can add so many more to these harms. So for sure, there is the stereotype problem. There's so many examples on stereotypes. If you check, for example, last year's ACL, there was a paper talking about llama and talking about the stereotypes that llama actually learns. And there was one example where they provided llama a sentence to continue. And the sentence was saying, Muhammad took the plane to blank, so to go to Hawaii or to travel to see his parents or whatever. And llama refused to continue the sentence. And llama said, it's inappropriate to talk about violence. So you can tell that llama has learned some stereotypes because the person has a Muslim name, and llama is now associating this in its response. So obviously it has learned some stereotypes from the data, or of course gender-related stereotypes and other stereotypes. There is toxic language. By toxic language, I mean harmful, offensive outputs. There is exclusion, when language models just exclude certain groups or say that they don't exist or just not present, or even misrepresent them. They can just represent them in an incorrect way, again, because of the data. Or, of course, the most famous bias type, which is just biased resource allocation. So you provide two candidates to an LLM and say, which one should we hire? And they have exactly the same qualifications. And the language model chooses one of them and not the other because of gender, race, whatever the reason is. But it's a biased resource allocation in the sense that it's just giving someone something and not depriving the other person from the same thing, even though they have the same qualifications. So those are some examples of language model harms. And this is why I decided to work on fairness during my PhD. And during my PhD, I had this question where I was thinking whether or not language models can also have biased thoughts. So I was thinking more from the point of view of an analogy with humans. Because if someone is racist, for example, then that person would take racist decisions, right? And these decisions are coming from a racist mindset. When we compare this to language models, we do know that language models can also take racist decisions. But what we do not know is whether or not they take racist decisions because they have racist mindsets. That's the question that I wanted to answer. So are they like us? Is it because when they have racist ways of thinking, they end up taking racist decisions? If yes, it would make them more human-like. It's still not ideal because they are also taking racist decisions, but at least it makes them more human-like. That was the question that I had. But then I realized that in order to answer this question, I have to find a proper dataset that has this thinking steps, because all of the bias datasets, they just measure the bias in the output. So I realized that there is a dataset called barbecue, and the way it is structured is that you provide questions. So for example, you would say there is this person from this race and there is this other person from a different race. They both are at the courthouse. Who's using drugs? And then the model would just provide an answer. And the answer would be either person A or person B, or I don't know. So I realized that with just small changes to this dataset, we can have a proper setting to answer my question, because we can just add the thinking steps before the answer. So for example, the model might say, oh, people from race A are always associated with drugs. And then my answer is the person from race A. So for me, this was an ideal setting to test to answer my question, which is whether or not biased models have biased thoughts. But then I also realized that I need to take a step back because something is missing. I still don't know how to measure the bias in the thoughts. We know how to measure bias in the output, in the decision. For example, if in this example, the model says that it's the person from race A, then that's a biased decision because there is no mention of anything related to that person using drugs. It's just completely based on their race. Similarly, if the model says it's the person from race B, again, it's a biased decision. The only fair decision or output in this case would be I don't know. So we know how to measure bias in the output, but we don't know how to measure bias in the thoughts. It's not very obvious. So how do we measure bias in the thoughts? Before I talk about what we did to measure bias in the thoughts, does anyone have any ideas on measuring bias in the thoughts? If I have some thoughts, let's say these thoughts, how would I know if they are biased or not? Any ideas? You can also ask clarification questions. Sorry, I don't see the chat, but can anyone?
So Suvik is saying, can we use another LLM as a judge?
Yes, absolutely. That's one of the things we did. Yes, of course. Yeah. That's one of our, any other ideas?
Feel free to unmute, by the way, guys.
I have a question idea. Can you reverse the, like structurally reverse the statement and then see if the thoughts are also the same when it's reversed? Do you know what I mean? Like,
No, can you clarify? What do you mean by reverse?
actually, never mind. Sorry, I was thinking out loud. No.
You reverse meaning that you put the thoughts as the question, right? That's
Yeah, kind of something like that, but I don't. I have to think it through some more.
no, actually, that's also another thing we tried, and it works. So we put the thoughts as the question, and you provide them to a classifier, and you see if the classifier is choosing I don't know or not. If the classifier is choosing I don't know, then the thoughts are good; they're not biased. If the classifier is choosing person A or person B, then the thoughts have biases in them. Is that what you meant?
It's along those lines, yes, but I hadn't got a full chain of thought going, so thank you for filling it in for me.
Okay. Okay. Any other ideas? Does anyone want to add anything? Okay. So, like was just mentioned.
Oh, there's like one more. I don't know if you want to take
Of
us.
course, yeah.
So Hadi is saying prompt pairing.
Transferring?
Prompt pairing. Is that something that you have?
Hadia, can you clarify what you mean by prompt pairing?
Yeah, maybe it's like something known that I don't know personally.
Okay, if okay, if Hadia is not okay,
Come back to it later, maybe at the end.
it's okay. So many of at least two of the ideas that were just mentioned are some of the methods that we tested, and they work. So the second idea that was mentioned was when the person said you reverse it. That's actually one of the things that we tried. You just check the probability. So you train a classifier on the thoughts. The input is the thoughts, and you check the output. If the thought is truly not biased, then you would have a high confidence for the I don't know option, and vice versa. If the thoughts are biased, you would find higher probabilities for person A and person B. Of course, that depends on maybe it's more, maybe it's from the model itself. So if the model is not perfect, then these numbers wouldn't be perfectly reflecting the bias, but it's not, it's an okay baseline that you can start with. So sorry?
Before you go into other slide. So she's saying prompt pairing, create pairs of prompts that are nearly identical except for one variable, then compare outputs.
I see. So if we want to apply this prompt pairing to the thoughts to know if they're biased or not, we would have version A saying people from race A are always associated with drugs, and version B, version 2 saying people from race B are always associated with drugs, and we see if this changes the output, right?
I think so. Seems like it.
I still, okay, I think I can get more clarifications from Hadia after the presentation.
Sounds good.
Yeah, but yeah, so the idea that was just mentioned before, Hadia's idea, is one of the things we tried. You just provide the thought and see the probabilities. It's basically the confidence. And that if the confidence is really high in person A or person B, you can accuse the thoughts of being biased thoughts. Or the LLM as a judge, as someone also mentioned, you just give the thoughts to an LLM, a different LLM, and ask whether or not the thoughts are biased. You can do more things. You can do embeddings as well. So you can get the thoughts and find an embedding for the sentence and get an unbiased answer, a fair answer, and find its embeddings, and then check if the embeddings are similar. So if the thoughts are truly unbiased, they should somehow have higher similarity with unbiased answers, right? Because they kind of are saying the same thing. You can also check hallucination detection methods. So people working in hallucination detection, they mostly focus on the faithfulness of answers. For example, you have a summary and you want to see if this summary is faithful to the text or not. So similarly, you can have the question. The question says a person from race A and a person from race B showed up at the courthouse who's using drugs. And you have the thoughts, and you see to what extent the thoughts are faithful to this question. If the thoughts are not faithful, then that means they are hallucinatory, and vice versa. So we use some of the hallucination detection methods, mainly a paper proposing a method called Haring Plus. So Haring Plus is a score. It's a hallucination score. And the higher the score is, the more hallucination you have, and obviously the more biased the thoughts are. And we can also use natural language inference. So for those of you who don't know natural language inference, it's a famous task in NLP where you have a premise and a hypothesis. For example, if you say Montreal is in Canada and Canada is cold, then Montreal is cold. So it's just, you can now say that this sentence is an entailment to the other sentence, because now that I know that Montreal is in Canada and that Canada is cold, I also know that Montreal is cold. So similarly, we use the same way. We had a premise. So now the premise would be the thoughts. People from race A are always associated with drugs. And the hypothesis is that this actually contains stereotypes. And then the NLI model would give you either entailment, contradiction, or neither. So obviously, if the hypothesis is valid, meaning if those thoughts contain some biases or stereotypes, then you would get entailment, and vice versa. Any questions on these methods before I propose another one? If there is a method that you think doesn't really make sense or you want to challenge it, we can also discuss that. If you have comments.
Hi. I'm sorry. I'm curious about the embedding. So you mentioned using embedding and then just using similarity search. I am just kind of a little bit confused because I know that I think embeddings can be used to capture like semantic similarity. But how does this exactly capture bias? Because it could just be that I don't know. I don't know. I'm just asking like a question that just popped in my head. Like I don't know does not necessarily say that I am similar to the thoughts, right? Or like the similarity amount in terms of, I don't know, is it cosine similarity, or do you get the question I'm trying to ask? I feel like it's halfway in some way, but I'm just kind of.
No, that makes a lot of sense. So the way we do it is that we're saying that if these thoughts are biased, when we embed them, so let's say the embedding has the meaning of the thoughts in some, so it's a vector, and this vector represents the meaning of these thoughts. If these thoughts are biased, they would be so different from the embedding of the fair answer, because they're just talking about some person who committed the crime, while the fair answer wouldn't have the same meaning. While on the other hand, if let's say the thoughts were not biased, let's provide different thoughts. Let's say the thoughts were saying there is nothing mentioned in the context about who's using drugs, so I don't really know. Let's say that these were the thoughts. So the embeddings of those fairer thoughts would be closer to I don't know than people from race A are always associated with drugs. It's not going to be perfect because you can always have misleading words or biased thoughts that have certain sentences that are fair and vice versa. But this is, so the embeddings for sure are for the entire sentence, not word embeddings. So they are contextualized. So if you have a higher similarity, it in some sense says that they are more agreeing with one another. And if you have a lower, it is cosine similarity, just in response to your question. But before the cosine similarity, there is a sentence transformer that provides the embeddings, the contextualized embeddings, if that makes any sense.
Yeah, I get it. It's okay.
Okay. If my answer is still not good enough, we can discuss it after the presentation if you wish.
There is one more hand lifted. Lima, do you want to unmute yourself?
Yeah. So could you clarify how you're associating hallucination with biased thoughts? Because, like, what if the hallucination is in terms of in accordance with whatever the thoughts are, and it's not really hallucinating, but it's actually biased. So I'm not clear on how are you associating it.
Okay. So You're saying that what if the thoughts are not? Can you repeat the last part?
I was just saying that what if it's not hallucinating, but whatever it's saying, like the thoughts are in accordance to the question that you have answered, and
Oh,
it's
I
not
see.
really hallucinating there.
I see. So all of the questions are posed in such a way that they don't convey any kind of stereotype or anything. So a question like this one does not contain any. So if the thoughts are, so by hallucination here, you can think of it as faithfulness. So if the thoughts are not faithful to the question, meaning, okay, let's talk about it from a mathematical perspective. If I condition a language model on the question and I see the probability of these thoughts, it would be a bit low because the question is in the direction of not really showing who is using drugs. So the probabilities of providing such a thought would be low when I condition on the question because they are not really aligned. The thoughts are different from what the question is.
Okay, makes sense. Yeah.
So by hallucination here, I mean not faithful. So think of it from a summarization perspective. Let's say the question is something you want to summarize, a text, and the thoughts are the summary. If you want to see if this summary is good or not, you would see how faithful it is to the text. If it is faithful, then it's a good summary, and if it's not faithful, it's not a good summary. So that's kind of how we do it as well. But this is based on the assumption that the questions are free from any biases, which is true.
Got it. Makes sense. Thank you.
Thanks for asking. Are there any other questions, or should I go to the next method?
I think you're good.
Okay. So far, all of the methods that we discussed, they were repurposed from existing methods. So we did not invent natural language inference, nor did we invent hallucination detection or embedding similarity and so on. These methods existed. We repurposed them to measure bias in the thoughts. However, we also have our own method that we proposed. We called it BRAIN, Bias Reasoning Analysis Using Information Norm. It's a bit long for a name. So BRAIN is what we are proposing in the paper, in addition to the other methods. So we're not trying to compete with the other methods. All of the methods eventually serve the same purpose, which is measuring the bias in the thoughts. They work differently based on the bias itself, as you will see in the results. So the point is not to outperform the others, it's just to propose a method that makes sense. So again, same question. Person A, person B showed up at the courthouse. Who's using drugs? The thoughts are saying there is nothing in the context that says who's using drugs, and then eventually the model would provide an answer. So the way BRAIN works is that it answers the question based on the context and question without the thoughts, and provides some probability distribution. And then again, it also answers the question with the question and thought without the context. So the idea is to see to what extent including the thoughts would make the probability distribution change. If the thoughts are biased, they would change the probability distribution drastically. If the thoughts are not biased, meaning that if the thoughts are in alignment with the question, the probability distribution would not change by much, if that makes any sense. So you would have two probability distributions. You can measure the differences in those probability distributions by using Jensen-Shannon divergence or any other measure of the differences in those probability distributions. Does that make sense?
It does. I had a question about when you include the thoughts versus how the thought changes the distribution. So what are you calculating your distribution on? Is it a combination of your context, question, thought versus the other scenario where you just skip the thought?
So the first is context question. The second is question thought. So the idea is just to see if including the thoughts makes any difference.
Right. Okay. Okay. Got it. Got it.
If the imagine if the thoughts are really biased, then including them would, change the probability distribution by a lot, because they convey some biased information. But if they don't have this stereotypical information, then whether you include them or not, it doesn't really matter, because everything is already in alignment with the question. So the more they diverge, the more biased the thoughts are.
Right. And you say in the second one where you include the thought, do you also have the context again, or no? You don't have the context anymore.
We don't include the context. It's question and thought.
And was there a reason for excluding the context, or
it's just because the thoughts already include enough context.
Right. Okay. Okay. Makes sense.
Yeah, but I think if you include the context, the results would still be fine. It's a good point.
Cool. Yeah, I just thought if there's like you're trying to make the minimal distinction, then maybe having the context also there would, yeah.
That's a good point.
Yeah.
So that is brain, and like I said, the objective is to measure the bias in the thoughts. So here I'm just comparing everything that I've just been talking about when it comes to measuring the bias in the thoughts for sexual orientation bias, race, and gender. You have NLI, which I discussed with the premise and hypothesis. LLM as a judge, as someone has just pointed out. Haring plus score, it's a score for hallucination. Brain, which I described. Span-based is the embedding method. Confidence is the probability method. So as you can see, different methods have they perform differently on different models. There's Gemma, Llama, Mistral, and other models. The higher, of course, the F1 score, the better we are at detecting bias in the thoughts. So if we want to find some winners, I would say brain and LLM as a judge. But if you look on the paper's appendix, you would see 11 different biases. So these are just 2. You would see that other methods are also competent on other biases. So like I said, the idea is not to say that there's this one method that beats everyone else. The idea is more to provide methods that make sense and show that on different biases, different methods might be best. So here, LLM as a judge and brain are the best 2. But if you check the paper, you would find that the others are also competent on other biases. So yeah, that's basically answers the question that I had in the beginning, which is how do I measure bias in the thoughts? Okay, so now that I know how to measure bias in the thoughts, let's go back to my question. So if you remember, I was asking a different question. I was asking if biased models have biased thoughts. This is the main question of the paper. I just had to answer this question because without answering this question, there is no way I can answer this other question, which I'm more interested in. So now it's a bit straightforward. You can just find the bias in the output, find the bias in the thoughts, and see whether or not they are correlated. That's basically what it is. And the answer was no. Biased models do not always have biased thoughts. They're not like us. They're not like human beings. Models can take biased decisions without necessarily having biased thoughts. So this experiment was done on 11 different biases and 5 different models. And what I'm reporting here is the correlation. So high correlation means if the correlation is 1, for example, it means that every time when the model takes a biased decision, it also has a biased thought. And -1 is every time when it takes a biased decision, it does not have a biased thought. So most of the correlations are positive, which means that there is a positive correlation, but it's not a 1 correlation. The highest correlation that we're having in this table is 0.56, which is not high enough for us to say that language models are human-like or that they are like us. When they take biased decisions, they have biased thoughts. That's not true. That was the main question. So answering this question for me was the biggest milestone. But then I also had some other side questions. So for example, if we make models think in steps, would that have any effect on the bias? And the answer was no. if models think in steps or not, it doesn't really affect whether or not they take biased decisions. So here, the y-axis is the fairness, and the x-axis is different models. And I'm comparing when I think in steps and when I do not think in steps. And the model's output is almost the same in terms of fairness. So thinking in steps is not going to neither improve nor degrade your fairness. It doesn't matter. And I also had another follow-up question, which is, would I benefit from injecting unbiased thoughts? Because think about it, if we can just inject some unbiased thoughts, maybe that would make the model take less biased decisions. So for example, if we go back to the example of the courthouse, if we tell the model after the question that we should not come up with conclusions based on someone's race and everyone is equally subject to being an addict and so on, if we add some thoughts that are fair, would that help? That's the question that I was trying to answer. And the answer is yes. If you add those unbiased thoughts, it does help. So again, higher F1 score means fairer models. And you can see that when you inject unbiased thoughts, it does help compared to, of course, if you inject biased thoughts. So this is a computationally efficient way of debiasing, because as you might probably know, in the literature, debiasing methods, not all of them are as computationally efficient as this one. There exist a lot of methods that require retraining the model from scratch. So if you can get this reduction in bias by just injecting unbiased thoughts, it's an interesting finding. So that's basically it. But before I conclude the presentation, just wanted to talk a bit about the journey. We already discussed it, but I had some screenshots from our journey from the beginning. So this is from October, when we were still trying to understand the problem. So as Swati mentioned, we were in 4 different countries and we never met in person. So I would just go to the whiteboard and write whatever we have, and we would discuss it. So that's from October, just trying to understand what the problem is. What does it mean to measure bias in the thoughts? And then we moved to more concrete questions. So this is when we started having our actual research questions. They are no longer scattered thoughts. They are actual research questions. So the screenshot on the left are the research questions that we ended up choosing in the paper. And on the right was just us discussing how we can put them in the paper and describe them. That was from Jan. And then towards the submission date, which was in March, as we were getting closer to that deadline, we were just running experiments. And then in March, we just had the final touches on how we should present the experiments and results. And on the right, this was the brain when it was still being thought of, when we were thinking of what is brain, what are we going to propose, and so on. Yeah, it was Shivang who came up with the idea. And finally, we just had the paper accepted at Column. So yeah, this was basically the journey. So what I'm trying to say is that I really encourage everyone to do open science if you could. I do think there is value in just working with one another without having to have an obligation. So I was not obliged to work on this project, and they were not obliged to tell me the updates, but we worked together on this project because we believe in open science. So I highly encourage anyone who's interested in open science to do the same. And that concludes my presentation. So the summary is that, unlike human beings, language models can actually take biased decisions without having biased thoughts. Thank you for listening. And I'm happy to take questions for sure.
Incredible. Thank you so much for presenting, and thank you to all the team, Swati and Dream and Shivang, for sharing your journey with us and celebrating with us today.
Yeah, it's a super cool paper. And just everyone in the chat, I encourage you to read the paper because it's such a great example of how one figure relates to one research question. I love that in the paper because now there's so many papers, there's 10 figures, so much information crammed into one figure that you're spending an hour trying to figure out what's the figure trying to say. So just amazing clarity in the paper as well. It's a great work.
Thank you, everyone. And thanks again, Esra'a, for starting all this.
Oh, and also my co-leads as well have played. I know that I was like front facing, but also my co-leads like Ruchira and Ujan have also played a huge role in helping manage this as well, and all the collaborations that happen in the Research Connections program. So shout out to them as well.
Okay.
But thank you. And are there any questions from the audience? Can you see this, Abdurrahman?
Yeah, thank you for the presentation. Suggestions you're thinking section of not consistent duties. This also says it can see the log or real things. Most practical. Thank you. Should they focus on prompt wrappers, output audits, or something else to monitor? Okay, so the question is saying, given that thinking in steps does not reduce bias, since most users cannot see or log the real thing, what is the most practical fairness technique you would recommend today? Should they focus on prompt wrappers, output audits, or something else to monitor or mitigate bias? So the question is, what is the most appropriate bias mitigation method to use right now? I think nowadays a lot of people do RLHF alignment and claim that this reduces bias, and it does work. But in my opinion, it also leads to models avoiding the question and trying to just talk about something else or just not answer. So there's a lot of refusals as well when the models confront such questions that can have biased answers. So even though retraining models from scratch is it's not as plausible as just doing these RLHF techniques, but I think fixing the data should always be the way to go, because if you keep doing those RLHF techniques, even though they might look like, so for example, if you take the stereotype example that I referred to when Llama was asked to continue a sentence about someone called Muhammad taking a plane, this was actually RLHF. So the RLHF taught the model to just avoid any question that could potentially lead to any violence. But think of it, if Llama had been trained on clean data, it would not have even had this problem, even though it's a more difficult fix. But I think it's the proper fix. That's my opinion. But of course, then that raises another question, which is, how would you clean up all of this data? Which is the topic of maybe a longer discussion. It's not very straightforward. But RLHF techniques have drawbacks, and you can see them when you try to hack these methods. They are easily hackable.
So saying thank you. So hopefully it answered the question. And are there any other questions? Cool.
Maybe I'm going to drop in with one more question.
All right. I know you're interested in this kind of thing.
Yeah. So I had a question. When you were comparing the different kind of methods, right? NLI and then brain and other things, did you find that some of the metrics or methods, they were more correlated than others? Did you do any kind of analysis on that?
That's a super interesting question. No, we did not do this experiment, but that's something I think that's worth thinking of, because the embedding, for example, based methods are so different from every other method we propose, because just the way they work is very different. But some of the methods that we are proposing kind of resemble other methods in the sense that they get similar information. So it's worth checking if there's a correlation between one method and others. I think it's an interesting question. So it all depends on the signal. So the embedding-based methods would take their signal from the embedding, the LLM as a judge. So some of these methods have similar signals in the sense that they operate based on similar input. So I expect that they would have a high correlation.
Right. Yeah. And I'm also curious because you say LLM as a judge and brain have like a very, you know, they look similar in the graph. But I think the brain seems much more, I don't know, information based. So I'm really curious if LLM as a judge is right for the right reasons compared to brain.
That's a good point. Yeah, I think it's worth checking. Yeah, thanks for bringing this.
Yeah. Thank you. Yeah.
Awesome. So we're at time, and this was really great having you all. And yeah, so I think we're gonna probably upload this to YouTube soon as well. So keep an eye on that. And thanks so much to everyone who attended. Have a great day, everyone, and goodbye.
Thank you, everyone.
Thank
Best
you.
of luck with your paper as well.
Thank you so much.